Ever pondered on the intricacies of the mechanical marvels that surround us daily? From the smooth operation of your car's gearbox to the seamless transition of power in your bicycle's chain drive, these feats of engineering are made possible by the principles of mechanical design. Today, we delve into this fascinating world, breaking down complex concepts into their easy-to-understand basics. Our journey begins with curves, not just any curves, but the ones that form the backbone of mechanical design. We have the basic curves, the building blocks of many mechanical systems, and then we have the advanced curves, which give us the flexibility to design complex systems. Combination cams, another vital aspect, allow us to create intricate motions by combining various cam profiles. From curves, we transition to the world of belt drives. Flat belt drives, for instance, are used extensively in many machines due to their simplicity. But what are they made of? Well, various materials come into play, each with its unique properties, and while they may seem simple, they are susceptible to issues like belt slip and creep that can drastically affect their performance. To design an effective flat belt or V-belt, it's crucial to follow a systematic procedure. This involves selecting the right type, material, and size of the belt, among other factors. Now imagine a world without conveyor belts. It would be chaos, right? Material handling systems, such as conveyor belts, ensure the smooth operation of many industries. But designing these systems is no walk in the park. It involves understanding the principles of material handling, the different types of conveyors, and the various safety devices required to ensure safe operation. Next, we delve into the world of gearboxes. These mechanical marvels are present everywhere, from your car to your washing machine. Designing a general-purpose gearbox requires a deep understanding of gear ratios, load conditions, and material selection. And when it comes to specialized gearboxes like those used in automobiles or machine tools, the complexity increases manifold. The use of design data in gearbox designing is paramount. It helps in making informed decisions about the type of gears to use, their arrangement, and the materials to choose. Our journey wouldn't be complete without discussing some key components of an engine. The crankshaft, connecting rod, cylinder, and cylinder head, each has a crucial role to play. The design of these parts is a complex process that requires a thorough understanding of the materials used, the forces they will be subjected to, and the conditions they will operate under. To solve design problems, one must approach the system in terms of its kinetics, kinematics, and power transmission, and it doesn't stop there. The design must also be optimal, which brings us to the concept of optimization. Optimum design ensures that the system performs its intended function with the least amount of resources. To achieve this, engineers use mathematical methods of optimization. One such method is Johnson's method of optimization, which helps in finding the best solution by considering multiple variables. To sum up, we have traversed the world of mechanical design, starting from the basic and advanced curves through the realm of belt drives and conveyor systems to the intricacies of gearbox design. We've also touched upon the design of engine components and the importance of optimization in design. The journey may seem complex, but with a solid understanding of these principles, the world of mechanical design becomes a playground for innovation and creativity.